In this video, we're going to look at how to use function notation to evaluate a function either for a specific numerical value or for a variable expression. So we're going to start off very basic and look at numerical values first. Now, when you're dealing with function notation is below f of x. So f parentheses x, you read it as f of x. So in the first example, we have f of x equals 4x plus 5. If we look at part A and part A says find f of negative 2. Part B says find f of 4. Now what this means, f of negative 2 means now your x is replaced with negative 2. So in the function, replace x with negative 2. So f of negative 2 means 4 times negative 2, 4x, plus 5. And then you just deal with order of operations, multiply 4 negative 2, and then add 5. So negative 8 plus 5 is negative 3. So really, if I examine what function notation looks like and what we did, function notation is just a fancy way of doing substitution for this. We're told f of x is 4x plus 5, find f of negative 2. Well, that means x is negative 2, so all we did was just plug in negative 2 for x and then do order of operations. So you can treat function notation as a fancy way of evaluating a variable expression using substitution. So if I have f of 4, that means x equals 4. So wherever I see my x, I replace it with a 4. So 4x, so 4 times 4, plus 5. Order of operations, 4 times 4 is 16. And then we add 5 to get 21. So that's a basic example of how to use function notation to evaluate at a specific value. Now in the following examples, we have one g of x. It's just another way of using function notation. You'll see f of x, g of x, h of x. It doesn't matter. It's just defining a function. So it's the same idea. G of 2 means x equals 2. So I plug in 2 for x. So x cubed becomes 2 cubed plus x, so plus 2. Order of operations, 2 cubed is 8. 8 plus 2 is 10. So with numerical values, it's not bad. Some students have problems when it comes to g of 3a because you no longer are plugging in a numerical value, you're now plugging in a variable expression, but it's still the same idea. You still replace your x with 3a. When you are using a variable expression, what happens is that becomes the new variable. You still follow the same concept. Wherever I see an x, I replace it with 3a. So if I have x cubed, what that really means is I have 3a cubed. Plus x means plus 3a. Now if we go back and think about how we deal with properties of exponents, if you have 3a cubed, what you want to do is cube the 3 and cube a. So 3 cubed is 27. So I have 27a cubed plus, drop down to 3a. Now a cubed and a are not like variables. They don't have the same exponents, so we cannot combine them. So that is our final answer. If we deal with g of 1/2, that means x is 1/2. So I have x cubed, so I'm going to put 1/2 in a parentheses and cube it, plus x, so plus 1/2. Remember, when you cube a fraction, what you do is you cube the top and you cube the bottom. So if you're raising a fraction to a power, just take the power to both the top and the bottom. So you get 1/8 plus 1/2. Now remember, you need a common denominator to add fractions. So 1/8 plus 4/8 is 5/8. And therefore, we know that function notation, if we're given either a numerical or variable expression, all you do is replace the variable for it. It's just a fancy way of doing substitution first, and then order of operations from there.